Hello guys and welcome to our math class. So for this video, I will be talking about the predicates and quantifiers, and this will be my first video for your class. So this is under the subject discrete mathematics. Okay, so for if you have any problem, by the way, if you have any problem about the lessons in week 1 and 2, you can just message me and then I can prepare a video again for you about the previous topic. Though I already uploaded videos from YouTube about those topics, but if you want a brief or a specific explanation, or if you want me to explain it myself for you, then I can do so. All you have to do is to message me, tell me if I still need to record a video about week 1 and week 2. So for now, I'll be um, discussing about the topic in week 3 and 4, which is the predicates and quantifiers. Okay, so for to start with, I would like to uh, talk about the word proposition and then the truth value. I would like to remind you that when we say truth value, it doesn't have to be true. Okay, truth value means that it can be false or it can be true depending on the values that you will use for the certain problem. Okay, so we have here P of x is greater than 3, which it says that it is not a proposition. Why? So as what is discussed in the module, in the week 1 module, proposition is actually the building blocks of logic. So everything goes around the proposition, the given proposition or the statement. Okay, so a proposition should be a declarative sentence. Okay, so when we say declarative sentence, it is a sentence that declares fact. That fact can be either true or false. So it doesn't have to be true all the time. For example, you have the sentence, Manila is the capital of Philippines. So it is a proposition, it is declaring a fact, and it's true. But when we say that Sorsogon City is the capital of the Philippines, it is a proposition, yes, because it is a declarative sentence, but it is false because Sorsogon City is not the capital of Philippines. Okay? So we have here, if we set value for x, which is 4, so that would be P of 4 is greater than 3. Okay? So let's say P of 4 will be equal to 4 since it is the values of x. It is the value of x rather. So it will be 4 is greater than 3. So it will be a proposition. Why? Because there is already the value of x, which is 4. And for this one, this is the truth value of 4 greater than 3 is true since 4 is really greater than 3. But if we put there P of 2 or 2 is greater than 3, then the truth value will be false. Okay po. Kasi po, magiging true siya since the given is 4 greater than 3, magiging true po siya if the value of x is mas malaki or higher, greater than 3. Uh, Greater than 3. If it's less than 3, then the truth value will be false. Okay? So next, so before I start with the definition of predicate and quantifier, I would like to give you some idea or a tip on how to understand logic in mathematics. Okay? First and foremost, you have to be um, reminded, or you have to have knowledge of your lessons in English about sentence, about predicate, about quantifier. So what you can do is to go on Google or YouTube and search for the meaning or in any book, English book, search for the meaning of the predicate or whatever word it is that we have to discuss in our subject. Okay? Because it's like we are solving problems in mathematical way, not in an English way. But uh, if you have idea in the English language, then it will be easier for you to do it in mathematical way. So if you can search for the meaning of these words before you go through our module, before you read the definitions in mathematical version, then it's better so that you already have an idea uh, what is a predicate, what is a quantifier, what is a proposition. So things like that. Okay, so for here, it is defined in English language that a predicate is a sentence or clause that modifies a subject. And then you are given their examples like John walked faster than James. And then the predicate there is walked faster than James, and John is the subject. Okay, next is you have John recited a poem to her classmates. So, recited a poem to her classmates is the predicate, and Joan is the subject. So, I have here subject as it is in a red color, and then predicate is in blue color, so that you can easily identify which is the subject and which is the predicate. So this time this is in a mathematical way, not in an English way. Okay, so you have here x is equal to y plus 3. So x there is a subject and equals y plus 3 is the predicate. Okay, for letter B, you have x plus y is equal to z. So x plus y is the subject and equal to z is the predicate. Next, you have letter C. Computer X is under attack by an intruder. So computer X is the subject and is under attack by an intruder is the predicate. And then letter D, you have computer X is functioning properly. So computer X is the subject and is functioning properly is the predicate. So, so I hope that it is clear to you what is a subject and what is a predicate in mathematical language, especially in logic. Okay, so let's have the definition of predicates. So it says there that predicates is a statement involving variables. So you have here that guy is going to the store. That guy is going to the store. So if you will think about it, if someone says that guy is going to the store, you will ask yourself, who? Like, sino ba? Sino ba ang pupunta? Sino ba sa mga, let's say there are 10 guys in a room, tapos may nagsabi, that guy is going to the store. You will ask yourself, magtatanong ka sa sarili mo, sino ba? Sino? Who among these 10 guys ang pupunta sa store, right? So, that's the problem. Like, what if it is stated in a mathematical way? Okay? Next, you have here x over 2 is an integer. Then, how can you say that x over 2 is an integer if you don't know the value of x, right? So, it will go to this. We can express these two things using predicates. So, it will be much easier for you to understand uh, since it is in a mathematical way. So it will be like, let p of x be true if x is going to the store. So as you can see there, there is a propositional function p of x. So let p of x be true if x is going to the store. So it can only be true depending to the value of x. Okay, so let's have this. Let q of x be true if x over 2 is an integer. Okay, so what we have here is the propositional function p of x. Okay, so If I have here, I hope you can see it. So let's say guy, that guy is that guy is going to the store, right? That guy is going to the store. So the first names we have Jose, Berto, and Dado. So let's say Jose is going to CCDI. So Jose is not going to the store. So meaning it is false. And then if Berto is going to the store, so meaning it is true. Then if Dado is going to the park, then it will be false. So, yun po siya. So, you have there, let's say, uh, so you can only set or you can only say that the value or the statement is true or the proposition is true if you already set values to the x. Okay, so it depends on the variable that you're going to use, by the way. So you can have Z, B, A. So it depends on the statement or on the proposition. I mean the statement that is in the problem. Okay, so you have there, let P of X be true if X is going to the store. So just like in the example, Jose is going to CCDI, so it's false. Berto is going to the store, so it's true. And Dado is going to the park, so it's false. Okay, and then let's have so let's have this example. Let P of X denote the statement X greater than 3. So you have what are the truth values of P of 4 and P of 2? Again, truth values, it should not, it's not only about being true or that the statement is true. It can be true or false, okay? So we have here the solution. What are the truth values of P of 4 and P of 2? So meaning you will set the values of X to 4 and 2. So for the first one, we have here 4 is greater than 3. So that is true. And then 2 is greater than 3, that is false because 2 is less than 3. So, just like what I've said a while ago, ang 4 po is mas malaki sa 3 or 4 is greater than 3, kaya true ang answer or the answer is true. But, since the second one is P of 2 and 2 is, it says that 2 is greater than 3, which is wrong, so the answer is false. Okay? So, next, you have here x is greater than 3 again. So you have the subject of the statement. We have the parts or the subject of the statement is the x, and then the other part, the predicate, is greater than 3. And then you have there, as what I've also said a while ago, the propositional function p of x. Okay, so let's have this one, the quantifier. So you have here quantifiers from a subclass under determiners. So just like what I told you before, that you can search on Google or any books or YouTube you have and search for the words, the dictionary, so that you have idea what is the word in English. With that, you can apply it in the mathematics language. Okay, so you have here, they are adjectives or phrases that serve to answer two possible questions: how many and how much. So um, just like the example before, let's say that the guy is going to the market. Let's say there are 10. Let's say there are 10 guys going to the market. Then uh, let's say two of them are going. So that answers the question how much or how many. I mean how many. Okay. So let's have the definition of the word quantifiers. So it is actually uh, process which is called quantification, or to create a proposition from a propositional function. So given the propositional function P of x, Q of x, C of x, you can create a proposition, because if you will not set values to that function, then it will not be a proposition. Okay, so you have quantification expresses the extent to which a predicate is true over a range of elements. So you have here, there are, it says, two more sentences that we can't express logically yet, but if we apply quantifier, then it will be a proposition, or we can express it logically. Okay, so the first one is everyone in this class will pass the midterm. And then the second one, someone in this room is sleeping now. Okay, so you have there, we can express the simpler versions about one person, wherein you can say X will pass the midterm and Y is sleeping now. Okay, so when we say, when you're having your test, okay, sometimes po, there are students that what they're saying is, okay lang yan, lahat naman tayo papasa. Okay? So, you're actually applying logic when you say that. Bakit? Why is it that you can say that lahat naman kayo papasa? Because of some reason. So that reasons can be the value of X. Okay, let's say the reason is that mabait ang teacher, or let's say one of the reason is madali lang yung subject, or maybe dahil may pandemic. So those are some of the values of X that you can apply for you to conclude that everyone in the class can pass the midterm. Okay? So, actually, we don't know, like, hindi mo alam, but parang you're already applying. Yun nga ang ano ng mathematics, 'di ba? Very abstract. Hindi mo alam, hindi mo napapansin na you're applying mathematics sa mga sinasabi mo, pero hindi mo siya napapansin kasi abstract nga. Pero in situations like that, nag-a-apply ka na pala ng logic. Nag-a-apply ka na pala ah, ng ah, isa na pala siyang propositional logic na hindi mo naman pala, hindi ka aware. You're unaware. Pero you're doing it. Okay? So, and then this one, why is he sleeping now? So, who among those students? Like, for the first sentence, everyone in this class will pass the midterm. So, it says that you are already concluding, or the statement is saying na lahat, so all, like everyone, will pass the midterm. Pero doon sa second statement, someone in this room is sleeping, ibig sabihin, merong isang tao na natutulog, pero hindi lahat. Okay? So, we have two types of quantifier. The first one is the universal quantifier, and it is defined as used to denote sentences with words like all or every. So just like in the first statement a while ago, everyone in this class will pass the midterm. So you use the word every. So we have here, when the notation is meaning for all x, p of x is true. So you have that the notation universal quantifier. So it is read as for all x, p of x is true, specifying a universal quantifier. So the domain, we need to specify the domain of the variable. Okay. So for example, here you have let p of x be true if x will pass the midterm. So the statement is everyone in this class will pass the midterm. So it is already a universal quantifier since the statement use the word everyone, every, meaning lahat. Lahat is involved. Okay? Next, so you have here another example of universal quantifier. So we have to find the truth values of these statements. So you have, let P of x be the statement x plus 1 is greater than x. What is the truth value? Okay. Um, you have there the truth value of the given is true, right? For every x of P of x is true. Why is that true? So x plus 1 is greater than uh, x. So let's say we set values for the x. So when we say po real numbers, so when we say real numbers, it means that we are dealing with every number. Okay, with every number, whether it's negative, positive, decimals, fractions. Okay, so for example, you have here, so you are given x plus 1 is greater than x, right? X plus 1 is greater than x. So you have, let's say, uh, let's say your P is 1, so you will have 1 plus 1. So your P of 1 is equal to, so meaning P of 1 is greater than x. Okay? Because the P of 1 is equal to 2, so it's right that P of 1 is greater than x. So let's say, for example, you set values for uh, P of x, which is will be P of negative 1. Okay, so negative 1 plus 1 is equal to 0. But still, it's greater than negative 1. Okay po? So, that's the idea. That's why it's true. So, whatever number you add sa 1, it's always greater than the number, greater than x. Okay? Um, the next one is let Q of x be the statement x is less than 2. So what is the truth value of the quantification for every x p of x where the domain consists of all real numbers? So it says there that Q of x is not true for every real number x. So sabi po doon, Q of 3 is false because if you already set values greater than 2 like 3, 4, 5, 6, the truth value will be false or it will not, the statement will not be correct anymore. Kasi ang 3, 4, 5, 6, and so on, higher numbers higher than 2, so yun nga, it's not less than kasi it's already uh, higher or greater than 2. That's why the truth value is false. Okay po. So, yun nga. So, pag nag-set ka ng value, pag correct ang statement, then the truth value will be true. And then if you set value and then the answer or the statement is wrong, then it will be false. Yun lang po ang pag-set ng truth values natin, okay? It depends on the value that you are going to use. So for this one, universal quantifiers, we are talking about the whole, lahat po. So when we say real numbers, we're not just pertaining to just one number. So we're talking about all real numbers because it is a universal quantifier. Okay? Unlike in existential quantifier, you have used to denote sentences with words like some or there is a. So the notation, there is at least one x where p of x is true. Again, we need to specify the domain of the variable. So we have here the given, someone in this room is sleeping. So this is the same sentence given before. Someone, you use the word someone, meaning pwedeng one of the people or one of the students is sleeping or maybe 2 or 3. So you can say it like that. So if the word is some, so it's an existential quantifier. But if the word is for every or for all, then it's a universal quantifier. So let's have an example, another example for existential quantifier. So same as given in the universal quantifier, you have let P of x denote the statement x is greater than 3. So what is the truth value of the quantification? For every x, P of x, now for some, uh, not for every x, I'm sorry. This is a quantification that means that there is uh, at least one x for P of x. Okay? I'm sorry, this is existential quantifier. So, there is at least one. When we say there is at least one, pwede pong isa, dalawa, tatlo, apat, but not zero. Okay? Pwede rin lahat. So, we have, but when we talk about all, it goes to universal quantifier already. For the existential, kahit isa lang pwede na, kahit dalawa lang pwede na. Unlike sa universal na kailangan lahat talaga. Okay? So you have what is the truth value of the quantification? Uh, there is at least one x p of x, so where the domain consists of all real numbers. Okay? So, let's have here the solution. So, ang statement po, the statement given is x greater than 3. So, you have here, x is greater than 3 is something true, for instance, when x is equal to 4. Uh, in existential quantification of P of x, uh, the truth value is true because there is at least one. There is at least one element na pag sinubstitute mo doon sa value ng x, nagiging correct ang statement. Okay po. So, you have here, so since this same problem is given to universal and existential quantifiers as an example, so you have here let P of x denote the statement x is greater than 3. So what is the truth value? Okay, so for the universal quantifier, it is false. And then for the existential quantifier, it is true. Why? For the universal quantifier, yun pong sabi ko sa inyo kanina, na the values should, all the values, meaning like all real numbers, since we're talking about real numbers, all the elements of real numbers, when you use it doon sa x, magsasatisfy siya sa statement that is x is greater than 3. But since not all real numbers will satisfy the statement x greater than 3, so the truth value for the universal quantifier is false. Okay, because if the value of x there is 2, so x is mas maliit po or mas maliit ang value kesa sa 3, so mali na po siya. So it's wrong. So hindi po pwede ganun si universal quantifier. Medyo ano po siya, medyo mahigpit. Hindi po pwedeng isa lang, hindi po pwedeng dalawa lang. Dapat po lahat. So parang when it comes to your classroom, when the school or when your teacher asks you to wear uniform, the whole class should wear uniform. Okay? So, required po yon na lahat ng mga estudyante mag-wear ng uniform. Pag isa sa inyo hindi na nakasuot ng uniform, mali na po yon para sa teacher because everyone is required to wear uniform. So, ganun din po ang condition ng universal quantifier. everyone should or every element should satisfy the statement. Okay? So for the existential quantifier, it is true. Why? Because it doesn't matter kung isa lang or dalawa lang ang mag-fit doon or mag-satisfy sa statement as long as na meron. So, for x is greater than 3, you can use 4, 5, 6, and so on. Higher numbers greater than 3. So, regardless, kahit na may maling isa, like 2, 1, or 0 pababa na number, kahit mali yun, walang pakialam po dun sa existential quantifier as long as merong kahit isa na tama. Like for example, um, in your classroom. So, same. Your teacher is medyo maluwag sa inyo. So, since, uh, for example, you're studying in a far-flung area, yung medyo malayo na ng mga school wherein uh, yung mga students hindi afford nila mag-uniform. So, anong nangyayari? Kahit isa lang sa mga estudyante ang naka-uniform, okay lang kay teacher kasi alam naman ng teacher na walang-wala yung iba. So, yun po. So, medyo maluwag si existential compare doon kay universal quantifier. Okay po. So you have here the quantification over infinite domain. So when we say infinite domain, you can have many numbers as you want. That's why it's infinite. Uh, just like all real numbers. So when we say all real numbers, any numbers that you know, pwede doon. So you have here quantification over infinite domain, meaning you can use 100,000 numbers that you can to satisfy the statement. Yung finite domain, quantification over finite domain, sometimes in the problems, they're only given, let's say, you can only use numbers from 1 to 10. So that is finite. Let's say you can only use even numbers from 1 to 100. So that is finite. So when you have that condition na sabi, dapat numbers lang from 1 to 10 ang gagamitin mo, that is finite domain. Pero pag sinabi that you can use any numbers, that is infinite domain. So that's the difference. So it says also that the universal and then the existential are in some ways like the conjunction and disjunction. If you can remember the topic in week 1 about conjunction and disjunction, so ito po siya. So if the quantification has infinite domain, so if the universal quantification has infinite domain, then it's using the conjunction and. So you have there the symbol. And then if the existential is using infinite domain, it's using the disjunction or. Okay? So this is the activity in your module, the do-it-yourself. I think most of you already tried to answer it. That's why marami nang nagreklamo na mahirap. But this is actually very easy. You just have to analyze the problem. So the problem is, let A of X denote the statement, computer X is under attack by an intruder. So yun po ang statement. You have to focus on that statement. Computer X is under attack by an intruder. And the subject there is the computer X. Suppose that of the computers on campus, you have only CS2. CS2 and Math 1 are currently under attack by an intruder. So meaning CS2 can be computer X, Math 1 can be computer X. Okay? So the question is, what are the truth values of A CS1, A CS2, and A Math 1? So if you are given ACS1 false, why is it ACS1 is false? So it is stated there that only CS2 and Math 1 are currently under attack by an intruder. Okay po. So, hindi po kasama si CS1 doon sa inattack ng intruder. That's why the answer is false. But when it comes to ACS2, so nandun po na-mention na only CS2 and Math1 are currently under attack by an intruder. So CS2 is true. And then when it comes to a Math 1, so since Math 1 is also mentioned as currently under attack by an intruder, so a Math 1 is true also. Okay, so um, this is the last activity in your module. This is a student assessment, so I already discussed it to you. This is actually uh, in the predicate part. So you have to analyze if it's true or false regarding or depending on the subject and then the predicate given. Okay, so I gave you assignments. So if there's still any questions regarding the topic, let's say you don't understand, just message me and just message me. Then I will just message me. Then I will answer you again using the LMS or um, using the LMS. Of course, you can add your questions in the forum in our LMS, then I can answer it there. And if there's still any other problem you encounter, like hindi pa rin talaga malinaw, hindi masagutan ng assignments because you don't understand it, then be specific on what part of the topic I have to discuss more so that I can again prepare a video for you. And if you have any example that you would like to discuss, you can send it to me so that I can answer it and discuss it again to you uh, via video. So next time, if you will ask, like if next time if you will ask if you still have problem, be specific po so that I know para hindi rin masyadong mahaba ang maging discussion natin about the topic. So when I prepare the discussion, it will focus more on the topic or the problem that you asked me. Okay? So I hope everyone understand the lesson for week 3. So I'll just be waiting for your responses regarding the video, the problem, and I hope everyone is safe. So sabi nga, keep safe and stop when you're proud of yourself. So I hope uh, I hope this video is helpful, and you can just inform me or feedback me if about the video. So I'm still looking forward on making more videos for you guys since I already know how to do it and I'm already proud of myself. But I won't stop. I will still be giving more videos for you because the teacher will never stop unless the students are proud of themselves. Okay? So keep safe, everyone, and bye.